The best thing in science is when you realize you understand how something works for the first time. At least to your knowledge, you're the only person on the planet who sort of understands the little secret. Why does a chili pepper have this sting to it? Why does this spider, when it stings you, elicit this painful sensation? All these things that we know occur, but we don't really understand the basis for it. So that's just curiosity. It's problem solving. It's a puzzle. The direction of my research has always been curiosity-based. I didn't start off saying I want to solve a disease or, understand a basis for a particular human disorder or clinical issue. In the back of your mind, you always know that whatever you discover in biology can be very relevant to a real translational problem. So that's kind of the best of both worlds, right? You can follow this curiosity-based route, but you know that at the end of the road, you're going to be making discoveries that will be relevant to human health.
The Nobel Assembly at Karolinska Institutet has today decided to award the 2021 Nobel Prize in Physiology or Medicine to David Julius and Ardem Pataputian.
And as Chancellor, I get to do many exciting and special things, but this absolutely tops it all. What an extraordinary day for David Julius. All of the people that have worked with David over so many years, and an extraordinary day for UCSF.
For discovering molecular cells and mechanisms underlying pain sensation.
The Breakthrough Prize in Life Sciences is awarded to David Julius.
I grew up in this part of Brooklyn called Brighton Beach. It was great because it was close to the beach, but it was connected to Manhattan by subway systems. So you can go over there and experience new things and culture. In terms of schooling, yeah, I wasn't a very good student in the beginning. My parents are college graduates. They went to Brooklyn College, so, the idea of going to college was sort of instilled in me. Why I went to MIT, I'm not exactly sure. A kid came up to me and said, if you're interested in science, you should go to MIT. It's very well known for that. So I applied, not really thinking about it. And then I got in. To me, the idea of going into science and in biology was really to go to medical school. When I went to MIT, I sort of quickly realized that I didn't really want to be a physician. And I started sort of poking my head into labs to see what was going on in there. And but at some point, I sort of got fascinated by the natural world. And for me, that was really understanding how natural products in our environment interact with ourselves and our physiology. The natural world is really the root. It's like evolution and all aspects of natural biology that really raise all the interesting questions. I've really liked that approach. It's a sort of grabbed me when I was a graduate student. And looking around Berkeley at the time, of course, there was a lot of exploration of natural products. And in pain research, natural products have played a pretty big role. But one of the key questions sort of focused on by the opiate crisis, and it's a big question in pain research in general, is can we develop other treatments for pain that don't rely on opiate analgesics? In the lab, we had, floated around this idea for a while of using capsaicin in particular from chili peppers to identify the receptors. Capsaicin, which is the main pungent ingredient, activates a subset of nerve fibers that are involved in pain sensation. And so as a molecular biologist, you want to understand pain. This is the question to answer. This is like the holy grail of pain research.
We have an opioid epidemic. Mm-hmm. What are other ways to solve this?
A big push in the field is to find new targets for different types of pain drugs that don't have, side effects of respiratory depression or addiction. The opioid epidemic is a major problem because of the consequences of, drug use, but it also exposes the burden that chronic and persistent pain plays out in society. Pain is a major unmet medical need. I don't know of anybody who hasn't suffered from some kind of persistent pain syndrome. A great outcome of our research would be if some of the molecules that we identified actually turn out to be targets for new types of drugs. And as that work continues and will continue in the future, I think will almost certainly lead to many new targets that can be put into the drug pipeline for treating chronic pain syndrome. My vision as a scientist is really twofold. One is to solve puzzles in nature and to interact with people, collaborators, and most of all trainees, and be a mentor to people. There's two things that I think a mentor can impart to their trainees that's important. One, of course, is rigor, and the other is getting out of your comfort zone. So for me, being chair, I think that's the most important thing in an institution. The goal here is not only to do some good science, but it's to set up this trajectory that then will launch them onto a path that's, unique for them, that they can use to establish their own lab. At some point, we do need to give up our space and our grants to the new generation so that those of us who have had our day in the sun can begin to transition out and give the resources to a younger generation. My end game is still just to make discoveries in basic research with the confidence of knowing that those discoveries will add to a body of knowledge that one day will be important for therapeutics.